Hello students, this is the lecture series of subject Object-Oriented Programming. This video covers the topic Functions and Scope of Variable. Myself, A. Nilima, Assistant Professor, Department of CSE, SRKR Engineering College, Bhimavara. The objective of this lecture are to study the concept of functions and their types, to learn about function overloading, to understand the concept of scope of variable. Coming to the function is a subpart of a program used to perform a specific task and is executed individually. We have two types of functions. One is built-in function and another one is user-defined functions. Built-in functions are also known as library functions. We need not to declare and define these functions as they are already written in C++ libraries such as IOStream, CMath, etc. We can directly call them when we need it. And this is the example for built-in functions. Here we are using built-in function power x, y, which is x to the power of y. This function is declared in CMath header file, so we have included the file in our program using #include directive. In main function, just I am calling the power function power 2, 5. Where this function definition will be in CMath. And we get the output 32 because 2 power 5 is 32. And coming to the user-defined functions, C++ also allows its user to define their own functions. We can define the functions anywhere in the program and then call these functions from any part of the code. Just like variables, it should be declared before using. Functions also need to be declared before they are called. Every function in C has the following. One is function declaration, another one is function definition, and the last one is a function call. Function declaration. In function declaration, the function declaration tells the compiler about the function name, the data type of the return value, and a parameter. And it is also called as function prototype. The function declaration is performed before the main function or inside the main function or any other function. For example, this is a syntax for function declaration: return type, function name, parenthesis in that parameter list, semicolon. Example: int sum, int comma int, where here we have declared a function name as sum, which takes the two integers as parameters and return value as integer. And here void swap int comma int semicolon, which is nothing but here we are declaring a function name as swap and we are passing the two parameters of type int, and it does not return any value and hence the return type is void. And coming to the function definition, which provides the actual code of that function. Function definition is nothing but which provides the actual code of that function. The function definition is also known as the body of the function. The actual task of the function is implemented in the function definition, which is enclosed in the flower base. This is the syntax for this: a return type, function name, parameter list, and whatever the code we have to include in this flower base. And this is the example. I'm declaring a function name as swap. I'm passing the two parameters. So this is the body of the function where I'm swapping the a and b values. And the function definition is performed before the main function or after the main function. And coming to the function call tells the compiler when to execute the function definition. When a function call is executed, the execution control jumps to the function definition where the actual code gets executed and returns to the same function call once the execution completes. And syntax function call is function name and parameters semicolon. Swap is a function name here, and we are passing the two values 10, 20. This is a function call. And function call is performed inside the main function or any other functions or inside the function itself. And this is the basic structure of a function. Okay, this is a main program where in that we are declaring a function prototype. Okay, in main function we will have a function call. Here function 1 is a function call. If this statement executes, it directly goes to the function definition, and there it executes the function body, and again it comes back to the statement where the control as transferred. Okay, next again it executes the next statement, function 2. So when this statement executes, it directly goes to the function definition, and after that it executes that function body of the function, and again the control transfers to the function call, and next step will be executed. This is the basic structure, and this is an example for that. Here I'm adding two numbers. Okay, this is the main function where I have declared x and y values as 20 and 100, and I'm calling a function sum x comma y where it executes this function definition, and it adds value and it stores in the result, and that result is written back so that that value will be stored into output and it displays the output. Next, an advantages of function. Using functions, the program implementation becomes easy. Functions make the program more readable and understandable. Once a function is created, it can be used many times, which is nothing but a code reusability. Using functions, larger programs can be divided into smaller modules. And coming to the passing parameters to functions. Okay. When a function gets executed in the program, the execution control is transferred from calling function to the called function and executes function definition, and finally comes back to the calling function. When the execution control is transferred from calling function to the called function, it may carry one or number of data values, and these data values are called as parameters. So parameters are nothing but the data values that are passed from calling function to the called function. And we have two types of parameters, actual parameters and formal parameters. Okay, actual parameters are nothing but the parameters that are specified in the calling function. And the parameters that are defined in the function definition are called as formal parameters. And we have two methods to pass parameters from calling function to the call function, and they are call by value and a call by reference. Call by value and a call by reference. Okay, in call by value parameter passing method, the copy of actual parameter values are copied to formal parameters, and the changes made on the formal parameters does not affect the values of actual parameters. That means after the execution control comes back to the calling function, the actual parameter values remain same. And in call by reference, the address of actual parameters is passed to the function and is received by the formal parameters. Whenever we use these formal parameters in called function, they directly access the memory locations of actual parameters. So the changes made on the formal parameters affects the values of actual parameters. And this is the example for call by value and a call by reference. Okay, where I'm swapping the values of two variables. Okay, this is the main function where I'm declaring x and y values as 5 and 7, and I'm calling a function swap where these values are copied into formal parameters a and b, and I'm swapping those values. So here I'm printing the value a and b, so I will get the value as 7 and 5. So after it controls statement returns back, it executes the values of x and y as 5 and 7. Okay, there will be no change in the actual parameters. Whereas in call by reference, if I copied, whatever the values are there in x and y, those values will be copied into formal parameters, and whatever the changes made in this formal parameters, that will affect in the actual parameters. So the values will be 7, 5 and 7, 5. And coming to the default parameters, in C++, we can provide default values function parameters. When we invoke the function, we don't specify parameters. We don't specify any parameters. Instead, the function takes the default parameters that are provided in the prototype. Okay. So in this example, I'm adding two numbers. Okay, from main, I have declared x value as 0, initialized x value as 0, and I'm calling a function sum. Here I have not sent any values or passed any values, but here I have declared values here in function definition. Okay, where you are initializing the values. So if you add up this x and y values, you will get a 20. Okay, and that value will be displayed on the output. Coming to the function overloading, the process of declaring multiple functions with the same name but different parameters is called as a function overloading. The function with same name must differ in one of the following ways. One is number of parameters, and another one is type of parameters, and a sequence of parameters. Number of parameters is nothing but, here we have the same function name, sum. Okay, but number of parameters are different. Here we have 2 parameters, and in this we have 3 parameters. And coming to the type of parameters, we will be having the same name, function name as same, that is sum. Okay, type of parameters are different. Here we have taken 2 integer types and here 2 double types. And next, sequence of parameters. Here function name is same, sum. Okay, int num1, double num2. And here we have changed the sequence of that. Double num1, int num2. Okay. And next, this is the example for the function overloading. Okay, where I'm adding 2 integer values as well as the floating values. Here in main function, I'm calling the function name plus function 8, 5. If this statement is executed, it directly goes to the int plus function int x, int y definition, function definition. So it adds the value and it returns the value as 13, and that value is stored in num1, and double my number2 variable is declared, and here I am calling a function of double type Okay, it goes to the function definition of double plus function, double x, double y. So where these values are copied here, and those values will be added and those are written back to my number 2. So I'm printing the value of both values, my number 1 and my number 2, where it prints the output as 10.56. And the advantage of function overloading is that it increases the readability of the program because you don't need to use different names for the same action. A scope of a variable. Variable scope is the region in which the variable remains active. The scope of a variable starts from the point it is declared. In C++, there are two places where variables can be declared. Okay, it can be declared either inside a function or a block, which is called as a local variable, and it can be declared outside of all functions, which is called as a global variable. Local variables have nothing but the variables which exist only between the curly braces in which it's declared. Outside that, they are unavailable and leads to compile time error. Here an example for the local variable. Okay, I'm declaring a variable I equal to 10, and here if I less than 20, okay, in that I'm gonna have declared a variable of n equal to 100. Okay, and this n will be in this within the scope, within this flower brace only of x. Okay, if you want to print this n value, it shows a compile time error. Okay, here value of n is not available here. This is for local variable. And coming to the global variables are those which are once declared and can be used throughout the lifetime of the program by any class or any function. They must be declared outside the main function. Only declared, they can be assigned different values at different time in program lifetime. And this is example for global variables. Here I have declared x about the main. Here I have initialized the value as 10 and I'm printing the x value, so it prints 10, and after that again I have assigned the value of x as 20 and it gives the output as 20. This is the output for that. First value of x is 10 and initialized again with value 20. And these are the topics we have discussed. Let's have a quick recap on this topic. Function is a subpart of a program used to perform a specific task and is executed individually. And coming to the parameters, it is nothing but a data values that are passed from the calling function to the called function. And default parameters are when we invoke the function, we don't specify the parameter. And function overloading, declaring multiple functions with same name but different parameters. Scope of a variable. Variable scope is the region in which the variable remains active. Local and global variables. If a variable is declared inside function or a block, then it is called as a local variable. And if a variable is declared outside of all the functions, then it is called as a global variable. Thank you.